Okay, let's do this example. It's slightly more complicated than the last one, but we can still describe it geometrically. So we've got this system, and I've already put that into octave, the matrix M. And so when I row reduce it, I get this. So the top row is 1, 0, 2/3, 4/3. Next row is 0, 1, negative 1/3, negative 5/3, and then a row of all zeros. Okay, so let's write this out. Let's see, x, y, and z. X and y are both have leading ones, but z is a free variable. So I'm going to write x is 4/3 minus 2/3 z. Y is negative 5/3 plus 1/3 z. And z is just z. So I'm going to write this as xyz is equal to 4/3 negative 5/3 0 plus z times negative 2/3 1/3 1. This is my solution. And let's see, this is xp, and this is xh. Now keep in mind, when you do xh, the z is part of xh. It's not just that vector there. So what we've got is we've got a vector. We've got a single vector in xh. So this is going to be a line. So geometrically, this is a line through the origin. Actually, no, this is a line in R3 that is parallel. Well, let me talk about two things. This right here is, you can think of this as kind of like the slope. This vector forms the solution to the associated homogeneous system. That's a line through the origin. This over here tells you how far to shift off of the origin. So this is a line in R3 that is parallel to negative 2/3 1/3 1 and goes through the point 4/3 negative 5/3 0. So this is a one-dimensional affine space. It's not a vector space because it doesn't contain the origin. If we were to try to draw this, and I'm not going to ask you to draw this, but if you were going to draw something like this, here's my x, y, and z. So it's parallel to the point negative, or to the vector negative 2/3 1/3 1. Now I can scale that by 3 if I wanted to, like this. So negative 2 1 3. So I'm going to go back negative 2, then 1 parallel to y, and then up 3 for z. So this vector here points off like that, and the other vector goes through this point. Now you can't scale this because this is a point that the thing actually goes through. If you go trying to scale that by some number, you can't. It's not going to be the same point. So 4/3 negative 5/3 0. That's going to be. Let's see. I'll do that one in green. 4/3 along the x-axis. So out here, negative 5/3 along the y, and then 0 along the z. So this is a point right here. And I'm going to take this this other vector, duplicate. I'm going to move that over here. So the solutions that we get are all of the points that go through, or all the points that are on that line right there. Maybe that's not the best visual in the world, but that's the solution set, and you'd write it out like this. All right.